Welcome back to Getting Started with Linux. I'm your host, Daniel Lowrie, joined by one Ross Brunson. We are going to look at managing files today. And Ross, we've been playing with files. This is kind of a bit of a series we got going within the series. We've worked with files that exist. We've created new files. But eventually we're going to want to do actual file management, right? I want to hit the big three, right? I want to be able to copy files. I want to be able to delete files. I want to be able to move files.
Right.
If you could you walk us through those scenarios?
Sure. Well, one thing to be aware of is that when you look at a Linux file system, there is a set of things that, if you understand them, makes your life a lot easier. The first thing to understand is that when we create a file on a Linux system, we use a thing called an inode, an index node. Now, this is completely obscured on other operating systems because you don't need to know that. You just need to know that it's a file. So the name of a file only occurs in the directory file that it is supposed to be in. So if I have a file in my home directory, the name of that file only occurs in that home directory, and it points to an index node, and the index node points to data.
Okay.
So the way to visualize that or understand that, let's switch over to our system here, and you can actually use the ls command to show you this information. So let's go into our test directory here just for fun. We do an ls minus li, and li says show me the long listing, but show me the index node number. So you see that I have an index node, inode number here, 8409224. That is unique amongst the entire rest of the system. And when we talk about things like creating symlinks, shortcuts, that kind of thing, we'll talk about those a little later on. It's the actual inode or index node that tells you what's really the deal with this file.
Okay.
So that's a very simple thing to understand. Remember, you've got the name, you've got the inode number, and you've got the data that actually occurs in the file, if any.
Okay.
Okay. So that piece is important. And what we can do now is we can think about the concept of copying on a system. When we look at copying, we're creating a new set of files. So if I copy one file from one directory to another, I am taking the original file, I'm creating a copy in memory, and I'm assigning a new index node or inode to it and putting it into that directory, wherever it happens to be. So if you run the ls minus li, you'll see that the same name of a file in a different directory, or somewhere on the system, will have a different inode number.
Okay.
When we do something like moving files, it's very important to understand that when we move a file, we're not really moving it per se, like picking it up and running somewhere else on the system and putting it down. I'm opening the directory file, taking the name that occurs in the directory file that points to the inode, that points to the, and taking that and taking it out, saving this one, opening the other directory file and placing it in there. Same inode, same disk location. No move.
So literally the file doesn't actually make any kind of movement.
That's right.
Just the reference to the file is in a different spot for the end user.
Yeah, exactly. And so move is actually kind of disingenuous.
Yeah.
It's not really a move. It's kind of like relocate the name. Yeah, but that's okay.
That's
Linux
right. As
and
long
Unix,
as it looks good, right?
Linux and Unix, it's anytime you think you've got a handle on it, sometimes it flips it backwards.
Yeah.
So that's very important. And when we do something such as a remove, an RM, what it does is it opens the directory file, takes the name that's there, that points to the inode, that points to the data, and simply pulls it out, saves the file, and it's done. Now, the index node is still there. The data is probably still there until the next time a open inode is needed or an open data block is needed, and then it just gets overwritten.
So it just flags it as, instead of
available.
Don't write over this, go ahead if you feel
like.
Like
the old DOS thing where you had the question mark in front of it that says, yeah, you can get that.
Yeah, go for it. Yeah.
Good old Norton disk doctor would get it back for you.
Awesome stuff.
Well, let's take a look at these, and let's go ahead and switch to our system, and let's do a little bit of copying. So for example, let's see, a good example would be, let's make a directory called test2, and we have three things in here. We've got file 1, file 2, and test2. If I wanted to, I can copy file asterisk to test2. If I do an ls in test2, and this is kind of an interesting thing to look at, when you run ls on files, it shows you the files. If I run ls on directories, by default, it shows you the contents of the directory. So let's use another command that may or may not be on your system, but I highly recommend it. It's something that I've used forever for demos. It's called the tree command. Oops. It's called the tree command. And the tree command shows us the relationship, the structure that we have inside this little directory. So we've got the two files, file 1 and file 2. We've got the test2 directory, and then file 1 and file 2. If I were to run an ls-li on file 1 and then test2 file 1, notice that they are totally different inodes. So they're not somehow, the same file just copied over here. It really is a copy of that into a new inode.
Right. So it opened the window and said, I'm going to take the contents of this down to the data from that inode.
Right.
Or make a new one, pop it over here. That way, if you're making changes to this one, doesn't make changes to that.
A copy is really a replication.
Yeah. That's a good way to put it.
Okay.
A clone, if you will.
Yeah, exactly. So now if you think about this, we now have, let's do our tree again so we can see our structure. We have file 1 and file 2. We have the test directory. What happens if I decide that I want to copy test2 to test3? Now, copy works a certain way with subdirectories, whereas the move command works a slightly different way. If I wanted to, I could literally say cp test2 to test3. Now, what's going to happen here is I'm going to get an error. It's going to come back and say, I'm sorry, you didn't speak to me properly, so I'm not going to do what you want. And the -r is the recursive. So copying a directory and its contents, you have to invoke the recursive option. So all I would do is up arrow, go back over here and do the -r. And now, if we'd run the tree, we see test2 and test3. So a cp-r of a directory will copy that directory and its contents to the new directory.
Okay.
Okay, so now we don't happen to have a test1, do we?
No, we do not.
Great, let's create one.
I like how you
by
think, sir.
moving test3 or test2
Into test1.
That's right. Now, let's show you a couple of interesting pieces about the move command. Move is recursive by default. So if I were to type mv test2 to test1, it's going to go and look in this directory, open up the directory file, take the source name, switch it to the target name, nothing else moves, saves the file. So now if I look at my tree, you see that we moved test2 to test1.
So more properly, and I guess in our minds, we could think of this as a renaming, because you said nothing actually moved.
Yeah.
Just kind of said, well, this is now test1 instead of test2.
Yep.
Okay.
So an MV, a move, is effectively a rename.
Okay.
However, one instance, MV and CP act very similar. So when you are on the same file system, the inodes and everything stay the same. Inodes are locked into a file system. If you're going from the file system A to file system B or across the network or whatever, a move is effectively a copy.
Okay.
So you really can't move. You can't open up and use the same inode from file system to file system. So a move across file systems is effectively the same thing. It is recursive by default, though. So there's still that CP has to be told to go into the subdirectories. MV automatically does it.
Ah, that's great.
Okay.
I love that. All right. Let's see. We've done copy. We've done move. What else do we have?
Let's
Remove,
blow some stuff
right?
up. Okay, let's get rid of some files here. Okay, so now we've got let's look at our tree structure here again. Let's give ourselves a interesting little structure to get rid of. We'll do an mkdir, and we'll have test 5, and we'll do mkdir test 5, and then test 6. So I've created a directory.
You have.
Now I'm creating a subdirectory in that directory. Okay. And when we run our tree command, you're going to see that we have test 1, test 3, test 5, and 6. Now, one of the interesting things about the rm command is that you have to tell it to go recursive. So if I wanted to do the removal of an entire directory structure, I would do rm -r, and that's recursive. This is one of those times when, if you're as a sysadmin signed on as root,
You start sweating.
yeah, you really check things and you say, maybe I should tab this out. I should use tab complete on this, because there's a big difference between /file and /file.
Yes.
That will attempt to remove the majority of your file system. So let's not do that. So rm-r, and we're going to get rid of test1. And when I do this, you'll see that test1, because rm-r, recursive, what it did is it went and it took the directory and everything in it. I could have had 1,000 subdirectories,
right,
and it would have wiped the whole thing out. Now, a lot of people look at this and they say, well, it did exactly what you said. Why, yes, it did. It did exactly what I said, and it didn't warn me.
No.
So as a root user, there's an option that's set by default called -i interactive. And as a root user, when you start removing things, it prompts you and says, did you really want to do that thing? If it asks you that, please double, triple check just to make sure. Now, quick little thing about removing directories. If I wanted to, I can use the rmdir command. So it's a relative of the rm command. If I type rmdir and then test5, I'm going to get an error. The rmdir command cannot remove non-empty directories. Test5 is non-empty because test6 exists in it. So I can use a little known but fun option of the rmdir command, and I can type rmdir -p for parent, and then if I say test5 and test6, it will get rid of that whole structure. So -p for creating directory structures. I could do mkdir dir1 subdir2 subdir3 with the -p. It'll just create the whole thing. And I can get rid of things like that, but they have to be empty.
Okay.
No getting rid of non-empty directories with the rmdir command.
Because you never know what's in that stuff, right? You don't want to blow some good information.
That's why
away.
you go look at them first.
That's right.
That's why the tree command is very, very helpful.
All right. Anything else we want to cover in this episode when it comes to managing
No,
files?
I think this is enough because we really have covered how to copy things, how to move things, and how to get rid of them,
The big
including those non-empty directories.
Awesome stuff. Thanks so much, Ross. And we do thank you for watching. Plenty more to come in this series, so stay tuned. And for now, we're going to call it a day. Thanks for watching.